Hello everyone. So today we are going to discuss LeetCode problem 350, which says intersection of two arrays part 2. Okay. So let's see what problem statement says. So we'll be given two integer arrays nums1 and nums2. We need to return an array of their intersection. Array of their intersection means we need to return the common elements. So each element in result must appear as many as times it shows in both arrays, and we need to return the result in any order. So order doesn't matter, but we need to return the intersection of both the arrays. Okay, let's see an example one where nums1 we have data as 1 comma 2 comma 2 comma 1, and the second array nums2 we have data as 2 comma 2. We can clearly see 2 comma 2 is common in both the arrays, that is nums1 and nums2. So in this case the intersection of nums1 and nums2 will be 2 comma 2. Let's see in second example. Here we have nums1 as 4 9 5, and in nums2 we have 9 4 9 8 4. We can clearly see 4 and 9 is common in both the arrays, that is the intersection of both the arrays will be 4 comma 9. Okay, now let's see how we can solve this problem. So according to the brute force approach, we will iterate through each element of nums1, that is the first array, and check each element that if it exists in the second array, that is nums2. If we find the element that is there in nums1 and also exists in num2, then we will add that to our result array, and then we will remove that element from the second array, that is nums2, to handle duplicates correctly. Okay, so let's look at the graphical way, or how we can solve this problem. Okay, so on the left hand side we have nums1 and on the right hand side we have nums2. Okay, now what does our approach says? Like, we will iterate through each element of nums1 and check that whether it exists in nums2 or not. Okay, so let's see, in nums1 the first element is 4. Okay, now we'll be comparing this 4 with each and every element of nums2 and check whether it exists in the second array, that is nums2, or not. Okay, so first we'll compare 4 with 9. So they both are not common, not same. Then we will compare 4 with the next element of nums2, that is 4. In this case we can clearly see this is common, so they both are same. So that means we will now take this 4 and store in the result set, because this is the intersection, this is the common element, and we will store this 4 in the result set. And after we store this element, we now need to remove this 4 from the nums2, that is the second array, in order to handle the duplicate, so that we don't take that again. Now we will iterate through the second element of the nums1, that is the first array. Now the second element is 9. Okay, so now we'll start comparing. In the first occurrence itself of the num2 we found 9. Okay, so whenever we find the element, we will store that element in the result set as 4 and 9, and we will remove this 9 from the second array, that is nums2. Okay, now coming to the nums1, that is the first array, we will now take the next element, that is the 5. Now we'll be comparing this 5 with all the elements of nums2. Okay, so we'll start with 9, so it is not matching. We'll check the next element, 8, it is not matching. We'll check the 4, it is not matching. So 5 is not matching with any of the elements, so that is, this is not the intersection element, this is not the common element. Now we have the result set as 4 and 9. Now we'll just return this array. Okay, so now let us understand the time complexity of this approach. So the time complexity will be big of n dot n, where m and n are the number of elements of array 1 and array 2, that is nums1 and nums2. And the space complexity will be big of 1. We are ignoring that output array. Okay, so now let us understand what can be the optimal way to solve this problem. Okay, so we will use the hash map to store the counts of nums1. That means we will store the frequency of the nums1 elements. Okay, and then we will traverse through the second array, that is nums2, and check if that element exists in the map or not. Okay, in the map, first we will store all the frequency of the first array. Okay, then we will traverse to the second array, and then we will compare with the map. If we found that element, then we will add that element to the result and decrease its count from the map, and at last we will return, okay, result array. So let's see an example. We created one map. Now we will be iterating through nums1 and we'll be storing the count of elements from the nums1. Okay, so first element is 4, so we encountered this first time, so initially its count will be 1. Okay, now let's see the second element, 9. It is also encountered first time. Now its count will be 1. Now next element is 5. It is also encountered first time. Its count will be 1. Okay, so we iterated through first array, that is nums1, and we have stored the count of each and every element. Now the second step says that now we need to traverse the nums2, that is the second array, that is 94984, and we will check that element found in the map or not. If element is found in the map, then we will add that element to the result set and we will reduce the count from the map. Okay, now the first element of nums2 is 9. Okay, so we can clearly see 9 is there in the map. So as soon as we find the element in our map, we will store that element into the result array, and then we will decrease its count. So initially its count is 1, now we will decrease its count from 1, it will become 0. Now let's take the next element of nums2 second array, that is 4. So we can see 4 is also there in our map. So as soon as we find the element in our map, we will store that element in our result array, and then we will reduce its count. So its count is 1. After we added that in result array, we will reduce its count from 1 to 0. So the next element in our nums2 is 9. Again we see 9 is there, but its count is already 0. If it counts is already 0, we will not add that to our result set, we will skip because we have already read that element. Okay, now let's see the next element in our nums2 second array, this is the 8. We can clearly see it is not present in the map, so we will not do anything, we'll skip this step. Okay, now the next element is 4. Again we can see 4 is there, but its count is already 0, so that means we have already taken this. Now we will skip this. Now we have iterated through the second array, that is nums2, and we have got a result array. So 9 and 4. Optimal approach, like what is the time and space complexity? So the time complexity will be big O of n plus n, that is the m is the number of element of nums1 and n is the number of elements of nums2, and the space complexity will be big O of m. Okay, now let's see the code part of it. We first declared an unordered map, int comma int. We will be storing the frequency here. Okay, and we have declared one result vector. Okay, now we are iterating through each of the elements of nums1 and we are storing the frequency. We are doing frequency of num plus plus. Here what we will be doing, we will be storing the frequency of each element of nums1. Okay, now again once we are ready with the map, that is the frequency, okay, map, now we'll iterate through the nums2 and we'll check if frequency of nums2 is greater than 0, that means that element exists. We will straight away take that element and push that into a result array, and then say at the same time we will be reducing its count to handle the duplicates. We'll do frequency of num minus minus, and at the last we will simply return the result array, result vector, where we stored all the intersection elements. Hope you like the video. Thanks for watching.